Alright everybody, welcome to today's video. Today we're going to look at reflections, and this is our third type of transformation we have looked at uh, concerning objects on the coordinate plane. Remember the first one we talked about was a translation. Remember the key word for translation was to slide, because all we did was move it from one part of the coordinate plane to the other. They did not change anything but location. Then the next one we looked at was rotation. Remember, rotation was also another transformation that changed the location, but it also changed direction of the object as it moved it around the coordinate plane. Remember, the key word we talked about for a rotation was turn, because that's what it's doing. You are turning it around a fixed point, and for us in 8th grade, we're basically just turning it around the center of origin. Okay, today we started in class, we looked at reflections, and that's what we want to talk about today. Let's kind of just go back and review what is a reflection. Well, if I look up here, reflection talks about, excuse me, okay, it's a rigid transformation that flips an image across a line of reflection. Okay, the reflected image is congruent to the pre-image, and each point of the reflected image is the same distance from the line of reflection. It's kind of like we talked about in class today about looking in a mirror. If you look in the mirror and if you hold up your right hand, the image in the mirror is going to hold up its left hand. If you move away from the mirror, the image is going to move away from the mirror. If you move close to it, it's going to come close to it. And if you reach out and touch the mirror, well, the image inside the mirror reaches in and touches the mirror. So it's just a reflected image. And when we see reflections everywhere, we talked about it we saw them today. We talked about in water, glass, mirrors, numerous places. Your cell phone, you take that selfie, when you flip it around, it's also going to have a reflected image. Okay. All right. What one word best describes a reflection? Remember, we talked about the two key letters right here of F and L. Well, remember the key word was flip. So now we have a turn, we have a rotate, we have a return, we have a slide, and now we have a flip. All right. What characteristics of an image change after it has been reflected? Well, location and direction. It's going to move it from one side of a line to the other, and it's also going to change the direction. And why is it called a rigid transformation? Well, if you remember, rigid means it's not going to change the size of an object. The object is the same. Remember, it's congruent, so it's going to have the same size, same shape, and same angle measurement. So that makes it congruent, but it's rigid because it does not change the size. Okay, so let's jump in and look at a few of these. Okay, remember, we want to look at reflecting these points across axes. Remember, and looked at these. We kind of talked about today. Let's kind of highlight these axes. Remember, we gave it the funny name of a squiggle. Well, I want to reflect this point above the squiggly line. Well, here T is above. I want to find T prime. Well, if you look, T is at -4, 7. But I want to take that point, and since it's above the line, well, if I go across that line, that means it's going to end up below. So if I count, remember, all we're going to do is count from this dot, from the T point, all the way to the line of reflection, which is my x-axis, and count the same number on the other side. We're going to mirror it on the other side. So just count 1, 2, 3, 4, 5, 6, 7. And then we're going to count 1, 2, 3, 4, 5, 6, 7. Okay, that would give me T prime, and now my coordinate here is -4, -7. Okay, remember we talked about today, you also could look at a really shortcut way to know the coordinate is, if I flip it across the x-axis, then all I'm going to do is change the sign of the y coordinate. Well, if you look, the -4 on my x, remember this is my x, this is my y. The x coordinate stayed the same, -4, but the y coordinate changed from a +7 to a -7. Okay, and you also could think about it too, because I'm in quadrant 3, both of the pairs should be negative. Okay, so all we're doing is counting, dot to the line and mirror. Okay, let's try one more. Let's see what we got here. We want to go to point M across the y-axis. Well, this time we're going to go across this axis. Remember, reflect across means we're going to go to the other side. Be careful here. Always want to go across. Don't highlight this one and go down. Okay, so we want to look. If I look, all I'm looking at right now, this point is at 6, 5 in quadrant 1. I'm going to reflect. Just count 1, 2, 3, 4, 5, 6. Just count the same number on the other side. When I put my dot, there is my coordinate for M prime, -6, positive 5, excuse me, not 6. Okay? And if you look at this one changed just a little bit, just in the fact that the rule changed because I went across the y-axis. That means the x coordinate has to change signs. If you'll notice, positive 5, the y stayed the same, the x changed. Or you can look and say, oh, I'm in quadrant 2, so -6, positive 5. So there's multiple ways to do this. Remember, you can choose which one you like. It's just a simple fact of learning that rule. I like you to know it because sometimes you may not have this coordinate plane to graph. And in a few minutes, you're going to see one of those. Okay? All right. Let's look at this one. All right. Now we got a whole shape. Here's what I want you to do. I want you to go ahead. Let's draw our squiggles. And I want you to go ahead and take just a second. And I want you to pause the video. And I want you to just see if you can figure out where it would go into which quadrant. Would it go into quadrant 4 or would it go into quadrant 3? I'm sorry, quadrant 2. So I want you to pause the video and then take a second, try it and see what you got, and then come back, okay? All right, welcome back. So let's see what we got. So let's go ahead and start with ABC. It's the same concept whether it's 1 dot or 3 dots or 10 dots. All we're doing is counting. 1, 2, 3, 4, 5, 6, 7, 8. Count the same number going up. Okay, there is A prime. Okay, B, 2, 3, 4, 5, 6, 7. Count up, there's 7, there's B prime. And then C, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There is C prime. Okay, there is my triangle. Okay, now don't be careful here because some people said today in class that looked like a rotation, and it does to a degree. But if you'll look where C is. C is still on the inside now. B is still on the outside. So it didn't rotate. All it did was flip across that line to the other axis. Okay, all right. Be careful with that one. And one way you can always do it is to write your coordinates and say, all right, what happened to my coordinates? Well, remember with a rotation, your coordinates are going to change if you go from one quadrant into the next, because if you just go 90 degrees, remember you have to switch and fix. So if you look at that, if you be very careful right here, but I'm just going to give you an example. Look at B. B is at -9, -7. Well, after the reflection, B is now at 9, 7. If you'll notice, the order of the pairs did not change, so it cannot be a reflection. So keep that in mind. I'm sorry, cannot be a rotation. So please keep that in mind and don't automatically assume that that is a rotation just because it went to that quadrant. Okay. All right. What about this guy? Okay. Well, look at here. This one, triangle LMN, a little bit different here because now I have 2 points that are on the line of reflection. Remember we talked about that today. It's really, don't let it bother you because it's actually the easier of the ones, because look at here. If I count N, N is on the line of reflection, so it has not going to move. So N is actually N prime. M, since it's on the line of reflection at 0, 2, then my new point for M prime is also 0, 2. Okay, well, N would be 0, 5, and then N prime would be 0, 5. Notice it didn't change. It's because it's on the line of reflection. It's kind of like we talked about that hand in the mirror. If you're looking in the mirror, your image is also touching the mirror. All right, so the only one we really have to move is L. So 1, 2, 3, 1, 2, 3. L prime. It's just a matter of counting, and it seems like a lot. Just take your time. You got this. Oh, that's too many lines. It's only a triangle. Okay, you got this. Just take your time with it. Okay, so these two are touching, so that's all it is just flipping that across the other side. It's kind of like you're taking your paper and you're folding this side all the way over here, and that's what would produce that triangle. Okay. All right, let's look at this one. This is a quadrilateral RSTU. We're going to go again. One more time, we're going to cross the y-axis. Okay. And don't let it bother you again. 1 point, 4 points, 5 points. Just count. Let's count triangle. Let's go R. 1, 2, 3, 4, 5. All we're doing is counting from the point to the line of reflection. So 1, 2, 3, 4, 5. Count 5 on the other side. There is R prime. U, 1, 2. S. and T. Okay, let me move that S prime because it's going to be probably going to get in our way. Okay, we'll say that's S prime, and then there's T prime. Okay, and naturally my hand drawn is not going to look near as neat as that, but that shape is congruent to that shape. Okay, so you will notice where, if you'll notice when I went across the y-axis, all of the when I went across the y-axis, all of my y's stayed the same. If you'll notice that, that's a 4, that's on 4, that's 3 and 3, okay, -3 and -3. Okay, the only thing that's going to change is the sign of the x value. Okay, all right, let's see what we got. Okay, now here's the same shape, but now we're going to change it up a little bit, and we're going to go across the x-axis. Okay, I want you to think about this a minute. Take a second, pause the tape of the video, and I want you to think, what did we do in class today? What is this going to look like? What's different? Okay, take a second, pause it, come back to me, and then we'll talk about it. Okay, so if you'll look, when we talked about this in class, what's different here is you have two points above the line of reflection, 2 points below the line of reflection. Well, guys, remember, it does not matter. That's not going to change anything as far as the rule-wise or the what I need to do. So all I'm going to do is count. From this letter U, I'm just going to count 1, 2, 1, 2. There is U prime. I'm going to count R. 1, 2, 3, 1, 2, 3. There is R prime. Then count S. 1. So S is one line. It's going to be one line above S prime, and then T, 1, 2, 3, 1, 2, 3, T prime. Because nothing changes. I don't want you guys to get sidetracked with that, because the rules are going to stay the same. You're going to just count. You're counting from the dot to the line of reflection. Now I know it looks funny, but that shape is also congruent as well. Let's see what we got next. All right, now we have our special case line. Remember, we gave you this today. I told you I would give you this. This is the case of y equals -3. We're going to reflect this across the y equals -3. Now, when we talked about this today, the rule where we say we flip across the y-axis, change the sign of the x, remember, it does not apply here because we're not going across the x-axis. We're going across this line, y equals -3. But the procedure is still the same. All you're going to do is count from here to the line. So 1, 2, 1, 2. There is G prime. 1, 2, 3. There is H prime. And then 1, 2, 3, 4, 5, 6. There is I prime. Okay, and let's just write these coordinates down real quick so you can see what I was talking about. Well, if I do G, here's my point of origin, so I go over 4, down 5, so that's 4, -5. This is what, 8, -6, oh, not -8. This is 8, -6, and I is 6, -9. Okay, those are my coordinates. So remember, if we don't want to get in the habit of saying just because we're over this axis, that's actually not the x-axis. So my coordinates are going to be different. Remember, when we plot our coordinates, we're going to start at 0, 0. Don't get tempted to start here. So if I plot G, 1, 2, 3, 4, that's 4, -1, 6, 3, and H prime is at 8, 0. Okay, notice how the numbers are different because we reflected over a line other than x or y axis. Okay, all right, I think we've got a couple more and then we're going to be done. All right, reflect this one, and I forgot to label this. Let's go ahead and label this A, B, C, D, and E. Okay, I'm going to change colors here. Let's reflect this one. So here's my squiggly line. I want to get in the habit of seeing that. Well, I see one right off the bat. I don't have to do anything with it. If I look right here, C is also going to be C prime. Okay, let's count B. 1, 2. Let's count D. 1, 2. A. 1, 2, 3. 1, 2, 3. And then E. 1, 2. I'm sorry. 1, 1. And what I have is this new shape. that's laying right on top of the other one. And if you think about it, my original shapes, I had 1, 2 on the left side, I had 1, 2 on the right side, and I had 1 on the line. And all I did was the 2 to the left went to the right, and the 2 to the right went to the left, and C stayed where it was. Okay? All right. I hope you're taking the time with this and pausing and seeing what you can come up with and rewinding and checking it out. Okay? All right, let's see. I think we got a couple more, and that's going to wrap us up. All right, this is what we talked about. Not always are you going to see E prime, D prime, G prime. You're not going to see the prime. Sometimes they will tell you in the image below, quadrilateral VWXY resulted from a transformation applied to quadrilateral DEFG. What it wants me to do is to draw the line of reflection and describe the transformation. Well, remember, first off, before we do anything, go back and remember V goes with D, W is with E, X is with F, Y is with G. Okay? And then side lengths, segment VW is congruent to DE. Okay? WX goes with EF, and XY goes with FG. And then finally on the outside, VY is the same as DG. So VY is VY here is the same as DG here. So what he wants to know is how did I go from here to here? Well, if I notice, everything should be okay. Let's look here. What I've actually done here is, if you'll think about it, and I tried to make sure I did a reflection, and what I've actually done is a translation, because everything is in the same place. So technically this is not a reflection, this is a translation. Okay, this is a translation according to the notation. What happened to this whole shape? It moved to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So I went left 10 places. So this is a translation of x minus 10. And I do apologize, guys. I wanted to make that what I want to do is I wanted to make it a reflection. So let's think about a second. I want to take a second and pause. What can I change real quick? What could I change to actually show that this was a reflection? Okay? If I want to reflect this, take a second and think about it, and then come back and talk to me. Okay? Welcome back. Well, remember, what I want to do is, I want to make sure that V and D go together and W and E. Okay? Well, W and E and Y and G go together, but here's the problem right here. If I reflect this 1, 2, 3, 1, 2, 3, that should have been point D, and then that should have been point F, because remember, distance is preserved. So that would have been, I'm sorry, that one would have been V. Excuse me, let me refresh that. Okay, this point over here, and I got it right, I just called it the wrong number. This should have been V, and this should have been X. I do apologize, and I don't want to confuse you, but sometimes I make the mistake, but if you catch that, you would have seen they were in the same order. Okay, so it's a translation X minus 10, but now what I've got is, once I fix those two letters, what I actually have is a reflection across the y-axis. Okay, I hope you picked up on that. If you didn't, now you can see what happens. Sometimes that's why I always go back to check your work. Now I fixed it. Now it is actually a reflection. Okay, sorry about the confusion. All right. I told you we were going to have some of these where you didn't have the coordinate plane to fix it, so you might want to learn a little bit of that rule about what happens when I reflect across the x-axis. Well, sometimes it does help to draw a coordinate plane. Remember, here's x, here's y. We can just say, all right, here, if I plot that point, remember quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Well, remember, we have plus plus. The x is negative, y is plus in 2, x is negative, y is negative in 3, and x is positive, y is negative in 4. Well, if I was to plot this point, it would be somewhere in quadrant 2, because it's negative x positive y, right? Well, if I reflect across the x-axis, if I come down here, remember, when I reflect, I don't change anything as far as order, so that's 2, 11. All I need to change is, if I go across the x, just change the sign of the y. And I'm in quadrant 3. Both of these are negative. Okay, so negative 2, 11 becomes negative 2, negative 11. There's A prime. Across the x-axis, the only thing that changed was the y-coordinate. Okay, I think this is the last one because that's a lot to think about tonight, especially after we worked as hard as we did today. Okay, all right, so here we go. Here we go. Triangle MNO with vertices, and you're given the vertices, is reflected across the y-axis. All it wants to know is what is the coordinate of O prime after it is reflected. Well, if I draw it again, I really don't have to draw it. Let's do it without drawing it. If all I know is O is at 11, 8, right? O prime, not Q, excuse me. O prime, the coordinates are not going to change. The only thing that's going to change if I go across the y-axis, just change the sign of the x coordinate. So 11, 8 becomes negative 11, negative 8. And again, if you need to draw this, there's nothing wrong with drawing this. Quadrant 1, 2, we're not going to do all the signs this time, and quadrant 4. Well, 11, 8 is somewhere here. I've just kind of figured. And if I go across the y-axis, well, there's my squiggles, which means I've got to go into quadrant 2, which lets me know negative x, positive y. Okay? Great job. I hope you've learned a little bit from this, and I hope you take an opportunity as we do this is to pause the video, let yourself think about a few things, and then try to do it yourself a little bit. Okay? Work it out yourself, and then check back with me. All right, any questions, please let me know tomorrow, and I will see you and have a great evening.